Hello, part 5 of this pendulum series, and well, it's always heartening when one thing leads to another. And so what you have is your standard meter has now defined by the speed of light. Understood for a while that the 30-degree pendulum, pretty much a maximum angle, needs to be a shallow angle to get 1 second. Already sort of meant, so 1 second at 45 degrees is 0.0093458. Mentioned earlier episodes, these margin of errors between these apparently unconnected units will give you the exact distance between one speed of light meter swinging on this pendulum and the exactly 1 second pendulum at 45 degrees north. Now we also, so that's the meter. Now that is E minus 1 feet, 1 Royal Egyptian Cubit. Pi over 6 meters is by definition 1 Egyptian Royal Cubit. That describes the pyramid. So each base is slight variations on each side, but effectively 440 Egyptian Royal Cubits on the base, 280 Royal Egyptian Cubits high. So if you create a 1 meter long exactly pendulum, you get 1 Egyptian Royal Cubit, which describes the pyramid. And that's sort of a nice connection to the English foot because it's E minus 1 feet equals pi over 6 meters. But now we have what was the Saxon foot, or the Royal Babylonian foot, or the Mohenjo Daro foot, which is 1.1 English feet. So this 3.3 feet equals 3 Indus feet, or Royal Babylonian cubits, or 1 Saxon yard. And because that is 1.00584 meters, it makes a slightly longer pendulum. So effectively it's pi over 6 meters plus 3 millimeters, which makes it 1.7278759, etc. feet, which is effectively 6 over 5, well, a canonical cubit of 6 over 5 cubed feet, or 1.728 feet. The difference between them is 38.1 microns. A human hair ranges from 40 to 120 microns. It's less than a human hair difference between this portion of arc and the canonical cubit, which John Michel and Robin Heath have mentioned. But what's nice about that is, okay, so this cubit also describes the Great Pyramid, including the sockets. So this cubit times 440 gives you the base, or times 880 the maximum visible base, and it also will give you the height of the pyramid times 280. This cubit times 440, or 880 for maximum, but 440 describes the pyramid including the sockets. If you look at the pyramid from a corner, especially the northeast corner, it gives you the rotational speed of the Earth per second. So this cubit here, which is based on the Royal Babylonian Indus/Saxon foot, or 3.3 feet, 33, gives you the speed of the Earth per second. Multiply that by 86,400, you get the equatorial circumference of the Earth. And you can do the same to get the height of the Earth, because this cubit again effectively describes the height of the pyramid, including the paving stones, at 280. The same numbers to give you these other proportions. But, it's like a plan of a Great Pyramid. Okay, we have the King's Chamber, or the upper chamber. That's like the sarcophagus. But the King's Chamber is 20 Royal Egyptian Cubits long and 10 Egyptian Royal Cubits wide. So this pendulum is also describing the units which describe the base of the King's, or the upper chamber, the central chamber in the Great Pyramid. However, now it's been measured, but also one of the ways you can work it out is that apparently the Egyptians didn't understand Pythagorean theorem according to the official version, But it just so happens that if you draw a line from that corner to there, and from the top corner to the bottom corner, what you get is a 3, 4, 5 triangle, this Pythagorean theorem which the Egyptian rope stretchers used, and you can find it in all the other pyramids connecting the Red Pyramid, Khafre's as well. But that's one, because therefore then you can work out, you know, the trig, and then you can work, we know the base and the width. Therefore it turns out that the height of the King's Chamber is 19.008 feet, which is a bloody lovely harmonic in terms of all these other units of measure, connecting so many ancient units of measure together. But what's really cool about that is that 1 metre defined by the speed of light gives you 1 Egyptian Royal Cubit on this second pendulum, which describes the pyramid, which also describes the base lengths of the King's Chamber. This slightly extended pyramid, which is based on the Indus Royal Babylonian / Saxon, or 33.3 feet, equals 3 Indus Saxon or Royal Babylonian feet. That describes the pyramid, including the sockets and the paving stones. However, it also describes this one, because it turns out that this is 11 canonical cubits, or this Indus Royal Pendulum Cubit, whatever, you know, there's no real, hasn't been named. So 11 of these gives you exactly the height of the King's Chamber. 20 of these gives you the base, or 10 gives you the length, or 10 gives you the width. So once again, these two units are describing different aspects of the pyramid and coming together. So at 19.08 feet on the Doric and the Ionic and the long foot, the / Persian foot, it also comes together. So, yeah, the Parthenon, for instance, which is proportion to the pyramid as well. So much bloody, anyway. It just keeps, you know, like you can't make it up. You know, there has, you know, the proportions, the numbers, the timing, just all blends in together, and you're always coming back to phi and pi and e, amongst other important math constants. And so, extraordinary symphony of coincidence is the only explanation that can be for it, because, well, there's some, you know, well, okay, I won't go into Campbell's chamber. The amount of data points that come together are just extraordinary. You can't make it up, and it just keeps, you know, like that's the thing. A theory will predict and keep coming back together, and it keeps coming back, and it comes back to harmonic numbers, these ancient, apparently unconnected ancient units of measure, and they're coming to, especially to earth-based measures and beautiful harmonic numbers which describe 108, 288, 3, 4, yeah, these on the harmonic series is all the ones that are embedded in throughout here. Now, for instance, the Grand Gallery, multiply the length of the Grand Gallery by phi, you get exactly the height. The pyramid itself is a 22/7 ratio, which is excellent definition of pi. If you actually include the exact measures, what you get is it's pretty much exact on. It's even better than 22.7. And the entire base perimeter of the King's Chamber is 60 Egyptian Royal Cubits, which makes it pi times 10 meters. And again, the metre, the cubit, the second, the ancient units of measure, so the English foot has been found at least 500 BC, at least. It's in the Salamis stone, and that just leads to other things. So these units, the margins of error describe exactly 1 second, and your 0.2 mil from this one, if you add that margin of error between the English and the Egyptian foot, if you subtract it, you get exactly 1 second at 45 degrees. If you add it, you get, again, within 0.2 mil, you get the description of this unit, and these units just keep coming back because, again, it describes the height of the king's chamber as well, which includes 3, 4, 5 triangle. Also, the sarcophagus, the exterior volume is exactly double that of the interior volume. So if you were to fill it with water, the volume of water inside would be exactly half of that of the entire sarcophagus, which is the delium problem, which again wasn't solved until Greek times and much later. It just keeps working, it blends in. King's chamber, Metre, second, pendulums, Indus, Royal Babylonian, Egyptian, and the allegedly modern foot and the allegedly modern Metre. There you go.